Okay, assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Iksan Purnomo. I am researcher in Mobile Communication Laboratory. I'm going to explain two things about fourth generation. The first is key technology of 4G LTE, and second is about carrier aggregation. Okay, before I explain further about this, I will explain little about 4G LTE because in the telecommunication market we often hear about 4G LTE. Actually, LTE is not 4G, or we can call it pre-4G or 3.9G. Why? LTE or long-term evolution is the next level of 3G UMTS, and 4G is the standardization of cellular technology which is required by IMT. One of required is has 1 gigabit per second for stationary user and has 500 megabit per second for mobility user. And LTE as a theoretical, it just has 100 megabit per second for stationary user and 50 megabit per second for mobility user. And then what are key technologies of LTE? The first is flat architecture.
Okay, this architecture divided by two parts. The first part is EU-TRAN as radio network and EPC as core network. And here there is a EUE or Evolved User Equipment. I will compare the architecture of 2G, 3G and 4G. In 2G, there are 5 nodes. 3G also has 5 nodes and 4G has 3 nodes.
In 2G and 3G, handover is handled by BSC and RANC, but in 4G, handover is handled by eNode P, so it will reduce the latency, so the data rate will increase.
The second is use MIMO antenna.
MIMO stands for multiple input, multiple output. MIMO technology is used in antenna configuration to increase the transmission and reception levels of the network. The highest configuration in MIMO technology is 4 multiplied 4 configuration. If the data from transmitter to receiver can be sent by many paths like that, like path 1, path 2, path 3 and path 4, or data from transmitter can divide and send in every pathwise like that.
The third is link adaptation modulation.
In link adaptation modulation, there are many options about the modulation. There are QPSK, 16QAM, and 64QAM. LTE has ability to modify the modulation scheme based on the characteristic of the transmission channel and the throughput requirement of the user.
And the fourth is use OFDMA for the downlink and SCFDMA for uplink.
In OFDMA, the function of orthogonality is used in which its symbol is at an angle of 90 degrees, so the symbol can never interfere. Okay, you can see in the picture that each carrier of LTE has 15 kilohertz. Hence, each resource block has 180 kilohertz, and each resource element can carry different data or same data. So this is the difference of OFDMA and SCFDMA. For the data rate, OFDMA is faster than SCFDMA because this is for downlink and SCFDMA for uplink. Okay, and why SCFDMA in uplink? Because in basically the user or user equipment is always uplink to the E node B. So if the uplink get faster than downlink, it will affect to the battery. Battery will empty so fast like that.
Okay, and then what is carrier aggregation? Carrier aggregation is a technique to increase the data rate and improve the capacity. Carrier aggregation technique attend in 4G LTE advanced or in release 10. For the simple sentences to explain about carrier aggregation is aggregate the carrier bandwidth. Before I explain further about carrier aggregation, we have to know about carrier bandwidth.
Okay, this is the bandwidth of every technology. 2G has 200 kHz, CDMA has 1.25 MHz, 3G has 5 MHz, and 4G have many option bandwidth like 1.4 MHz, 3 MHz, 5 MHz, 10 MHz, 15 MHz, and 20 MHz. And this is the bandwidth will aggregate. So if the bandwidth will aggregate till 100 MHz, the data rate can increase.
The high peak data rates and average throughput per cell are supported by the LTE advanced system with the wider bandwidth. LTE Advanced use carrier aggregation with two or more component carrier, or we call it CC, so that the bandwidth larger than 20 MHz can be supported. The multiple component carrier are used to transmit or receive data when required bandwidth capability is beyond 20 MHz. The transmission bandwidth of up to 100 MHz can be low by aggregating up to 5 component carriers. In LTE Advanced, there are 3 carrier aggregation types depending on the usage of the spectrum. There are intraband contiguous CA, there are intraband contiguous carrier aggregation, intraband non-contiguous carrier aggregation, and interband carrier aggregation. In carrier aggregation, each component carrier corresponds to a serving cell. The different serving cell might have different coverage. Okay, there is an example for interband non-contiguous. There are a term like PSC or primary serving cell and secondary serving cell or SSC. In LTE Advanced, there are 5 different scenarios for carrier aggregation, in which 2 different component carrier frequency F1 and F2 are considered in a cell. Frequency 2 are bigger than frequency 1. These are the 5 scenarios of LTE Advanced for carrier aggregation. Okay, that's all from me. Thank you for your attention. I'm sorry if my English is still bad. I will improve it. Thank you. Assalamualaikum warahmatullahi wabarakatuh.